Welcome to everyone to this live podcast on Post Scientist on Twitch. Well, most of you guys don't really know what this Post Scientist is, so let me explain it for you. Post Scientist is a blog website in which you will get blogs or articles about science related fields. But we have decided to take step forward and start this podcast so that people who are love to listening or don't have much time to reading those blogs can listen these blogs. So we on the daily basis we have started these streams, and by this time only we are live on Twitch. So if you are uh, watching me, then please follow me for better better understanding or anything, and also follow our socials, especially Twitter, because we are mostly active on Twitter, and you get mm, many information from that. So yes, and that's all about it. Let's get started with our first article or the first blog, which is attention based deep neural network increases detection capability in sonar systems. Well, it's basically between India and sorry, it's between in South China Sea, between between China and US. And how it the deep neutral network is helping and increases detention, and can also target the enemies submarines, you can see in this blog. So yes, in underwater acoustics, deep learning is gaining traction in improving sonar system to detect ships and submarines in distress or restricted waters. In underwater, sorry, once again. In underwater acoustic, deep learning is gaining traction in improving sonar system to detect ships and submarine in distress or in restricted waters. However, noise interference from the complex marine environment becomes a challenge when attempting to detect targeted ship radiated sounds. In the Journal of Acoustic Society of America, published by the Acoustical Society of America through AIP Publishing, researchers in China and the United States explored an attention based deep neural network ABNN to tackle this problem. Sorry. We found the ABNN was highly accurate in target recognition, exceeding a conventional deep neural network, particularly when using limited single target data to detect multi targets, co author Kunyan Rain said. Deep learning is a machine learning method that uses artificial neural network inspired by human brain to recognize pattern. Each layer of artificial neurons or nodes learn a distinct set of features based on information contained in the previous layer. A ABNN uses a attention module to mimic elements in the cognitive process that enable us to focus on the most important parts of an image, language, or other pattern and tune out the rest. This is accomplished by adding more weight to certain nodes to enhance specific pattern elements in the machine learning process. Incorporating an ABNN system in sonar equipment for targeted ship detection, the researchers tested two ships in a shallow 135 square mile area of the South China Sea. They compared their result with a typical deep neural network DNN, radar, and other equipment were used to determine more than 70 interfering vessels in the experimental area. They found The ABNN increases its production considerably as it gravitates toward the feature closely correlated with the training goals. Detention becomes more pronounced as the network continually cycles through the entire training dataset and accentuating the weight nodes and disregarding irrelevant information. While the ABNN accuracy of detecting ships A and B separately was slightly higher than the DNN in 98% and 97.4% respectively, and the ABNN accuracy of detecting both ships in the same vicinity was significantly higher, 74% and 58.4%. And multiple respect for multiple target identification, a traditional ABNN model is generally trained using multi-ship data, but this can be complicated and computationally costly process. The researchers trained their ABNN model to detect each target separately. The individual target dataset then merged as the output layer of the network is extended. The need to detect multiple shifts at one time is a common scenario, and our models significantly exceed DNN in detecting two shifts in the same vicinity, Wren said. Moreover, our ABNN focused on the inherent features of the two shifts simultaneously. So, you get the news around that in which US submarines have been attacked or something like that. So I think that's the research, and that's the uh, test is going on between their scientists. So yes, that's all about it. Now we have next topic, which is storing data is mixture of fluorescent dyes. uh, Tomorrow we have discussed that storing data in our DNA, or uh, our DNA can become our the tiniest hard drive, and now we are storing data as mixture of fluorescent dyes, like in chemistry, right? Interesting. Never mind. As the world data storage needs grow, new strategy for preserving information over long period with reduced energy consumption are needed. Now, researcher reporting in ACS Central Science has have developed a data storage approach based on mixture of fluorescent dyes which are deposited onto an epoxy surface in tiny spots with an inkjet printer. The mixture of dyes at each spot encodes binary information that is read with a fluorescent microscope. Current device of data storage such as optical media, magnetic media, and flash memory typically last less than 20 years, and they require substantial energy to maintain stored information. Scientists have explored using different molecules such as DNA or other polymers, like we discussed earlier, to store information at high density and without power for thousands of years or longer. But these approaches are limited by factors such as high relative cost and slow write speed. George Whitesides, Amit Nagarkar, and colleagues wanted to develop a molecular strategy that stored with information with high density, fast read, write speed, and acceptable cost. Of course, the researchers choose seven commercially available fluorescent dye molecules that emit light at different wavelengths. They used the dyes as bit for American Standard Code of Information Interchange (ACSII) characters, where each bit is a 0 or 1 depending on whether particular dye is absent or present respectively. A sequence of zeros and ones was used to encode the first section of his seminal research paper of Michael Faraday, the famous scientist. The team used an inkjet printer to place the dye mixture in tiny spots on an epoxy surface where they become covalently bound. Then they used a fluorescence microscope to read the emission spectra of dye molecules at each spot and decode the message. The fluorescent data could be read 1000 times without a significant loss in intensity. The researchers also demonstrated the technique ability to write and read uh, an image of Faraday. The strategy has read rate of 4469 bits, which is the fastest reported for any molecular information storage method, the researcher says. Of course. Now we have our next topic or next article, uh, which is toward more energy efficient power converters. Hmm. It's basically there is a metal or a thing who can uh, through which uh, the electronic devices which consume more power can consume less power after this metal is introduced in this electronic devices. So yes, and now let's read this article. Scientists from Nara Institute of Science and Technology use a mathematical method called automative differentiation to find the optimal fit of experimental data up to 4 times faster. This research can be applied to multivariable model of electronic devices, which may allow them to design with increased performance while consuming less power. Yes. Why wide band gap devices such as silicon carbide, metal oxide semiconductor field effect transistors are a critical element for making converters faster and more sustainable. This is because of their larger switching frequencies with smaller energy losses under a wide range of temperatures when compared with conventional silicon based devices. However, calculating the parameter that determine how the electrical current in a MOSFET responds as a function of the applied voltage remain difficult in a circuit simulation. A better approach for fitting experimental data to extract the important parameters would provide chip manufacturers the ability to design more efficient power converters. Now, a team of scientists led by NIAST has successfully used a mathematical method called automated differentiation AD to significantly accelerate these calculations. While AD has been used extensively while when training artificial neural networks to current project extends its application into the area of model parameter extraction. For example, involving many variables, the task of minimizing the error is often accomplished by a process of gradient descent in which an initial guess is repeatedly refined by making small adjustment in the direction that reduces the error the quickest. There is where AD can be much faster than previous alternatives such as symbolic or numeral differentiation finding direction with steepest slope. AD breaks down the problem into combination of basic arithmetic operations, each of which only need to be done once. With AD, the partial derivative with respect to each of the input parameters are obtained simultaneously, so there is no need to repeat the model evolution evaluation for each parameter. First author Mikihiro Shitani says. By contrast, symbolic differentiation provide exact solution provides exact solutions but uses a large amount of time and compu- computational resources as the problem becomes more complex. To show the effectiveness of this method, the team applied it to experimental data collected from a commercial available SiC MOSFET. Our approach reduced the computation time of by 3.5x in comparison to the conventional numeral differentiation method, which is close to maximum improvement, particularly Pintani says. This method multiple variable since it preserves the physical meanings of model parameter. The application of AD for enhanced extraction of metal will support development and quantum application. Quantum but is like 0 to 9 and or not to 9 but 0, but in a faster way, like 8 core process have amazing speed and amazing than the 8 core processor, same something like that. So now we are now now the classical uh, every researcher is researching in this study. So there is a way or the key is so it will be easy like a processor only. Then it will which which we all are used. So what's from TU Wayne Vinia could be an important is metal heterostructure. Chemically controlled with electric fields. This make it excellently suited for a complex quantum technologies processing quantum technologies instead establish enable electronic. The result however, if it is components extremely difficult high qual- quality electrical contacts. This is related to the high impact of even smaller impurities at the contact point that significantly after the electrical properties. We have therefore set ourselves the task of developing a new manufacturing method that enables reliable and reproducible contact properties, says Maiser Sistani. Diffusing atoms. The key is temperature. When nanometer structure germanium and aluminium are brought into contact and heated, the atoms of both materials begin to diffuse into the neighboring material. But to very different extent, the germanium atoms move rapidly into the aluminium, whereas aluminium hardly diffuse into the germanium at all. Thus, if you connect two aluminium contacts to the thin germanium nanowire and raise the temperature to 350 degrees Celsius, the germanium atoms diffuse off the edge of the nanowire. This creates empty space into which the aluminium can then easily penetrate, explained Maiser Sistani. In the end, only a few nanometer area in the middle of the nanowire consists of germanium. The rest has been filled up by aluminium. Normally, aluminium is made up of tiny crystal grains, but this novel fabrication method forms a perfect single crystal in which the aluminium atoms are arranged in a uniform pattern, as can be seen under the transmission electron microscope. A perfectly clean and atomically sharp transition is formed between germanium and aluminium with no disordered region in between. In contrast to conventional method where electrical contacts are applied to a semiconductor, for example by evaporating a metal, no oxide can form at the boundary layer. Quantum transport in general, general Grenoble. In order to take a closer look at the properties of the monolithic metal semiconductor heterostructure of germanium and aluminium at low temperature, we collaborated with Dr. Olivier Buisson and Dr. Cecily Nord from the Quantum Electronics Circuits Group of Neil Institute CNRS UGA in Grenoble. It turned out that the novel structure indeed has quite remarkable properties. Not only we able to demonstrate superconductivity in pure undoped germanium for the first time, we were also able to show that this structure can be switched between quite different operating state using electrical fields. Such a germanium quantum dot device can not only be superconductive conducting but also completely insulating, or it can behave like a Josephson transistor, an important basic element of quantum electronic circuits, explained Meiser Sistani. This is a heterostructure combined a whole range of advantages. The structure has excellent physical properties needed for quantum technologies, such as high carrier mobility and excellent manipulability with electric field, and it has the additional advantage for fitting well with already established microelectronic technologies. Germanium is already used in current chip architectures, and the temperature required for heterostructure formation are compatible with well established semiconductor processing scheme. The novel structure not only have theoretically interesting quantum properties but also opens up technologically very realistic possibility by enabling further novel and energy saving devices. Now you seen the quantum electronics thing and to how to uh, reduce the size or compact the size, compacting the size. It's the key of germanium. Germanium is the metal for compact the devices of quantum applications. Now we have our next topic, which is liquid metal proven to be cheap and efficient CO2 converter. A global uh, collaboration led by researchers from UNSW has shown how liquid gallium can be used to help achieve the important goal of net zero carbon emission. As engineers from UNSW have helped to discover a cheap new way to capture and convert CO2 greenhouse emission using liquid metal. It's a new way uh, and cost effective. Uh, so it will be easy for everyone basically to convert CO2 into O2. The process can be done at room temperature, uses liquid gallium to convert the carbon dioxide into oxygen at high value solid carbon product that can be later be used in batteries or in construction or aircrafting manufacturing. Of course, a team from the School of Chemical Engineering led by Professor Kor- Korosh Kalantar Sade worked in collaboration with researchers at University of California, Los Angeles, UCLA, North Carolina State University, RMIT, University of Melbourne, Queensland University of Technology, and the Australian Synchrotron. Their findings have been published in the Advanced Material Journal, and Professor Kalantar Zadeh and his team say the new technology has the potential to be used in wide variety of ways to significantly reduce the level of greenhouse gases in the atmosphere. We see very strong industrial application with regard to decarbonization. This technology offers an unprecedented process for capturing and converting CO2 at an exceptional competitive cost, said Junma Tang, the first author of the paper. The application could be in cars to convert polluting exhaust gases, or even at much larger scale at industrial sites where CO2 emission could be immediately captured and processed using this technology. We have already scaled this system up to 2.5 liters dimension, which can deal with around zero point 0.1 liter of CO2 per minute, and we have tested that running continuously for a whole month, and the efficiency of the system did not degrade. The newly discovered process dissolves, capture CO2 gas into a solvent around nanoparticles of gallium, which exist in liquid state above 30 degrees Celsius. The reactor also contains nano-sized solid silver rods that are the key to generating the triboelectrochemical reaction that take place once mechanical energy is introduced. A tribo A triboelectrochemical reaction occurs in solid-liquid interface due to friction between the two surfaces with an electric field also created that sparks a chemical reaction. The reaction breaks the carbon dioxide into oxygen gas as well as carbonous sheets which float to the surface of the container due to differences in density and can therefore be easily extracted. In this paper, the research team show a 92% efficiency in converting a ton of CO2 as described using just 230 kilowatt of energy. They estimate this equates to a cost of around $100 per ton of CO2. Very cost effective technology. In order to commercialize the research, a spin out company called LM Plus has been established with the support of UNSW Knowledge Exchange, a program that helps transform research discovery into successful innovation to benefit society, along with seed invested from Uniseed. I hope so. This technology will come as soon as possible in the market. Now we have our next topic, which is a model to classify financial tests while protecting users' privacy. It's basically data security or cyber security thing. Uh, Nothing like that. I'm gonna say this in the whoever is in the computer field or software field, basically, you have a right. I mean, you have done a lot of things. You can protect a lot of data, a lot of person privacy data. So please be careful and always be ensured that you can never fall into a trap or of any scammers or by the companies also, that you have to be very update updateful or uh, very efficient about your uh, customer privacy data, because otherwise your company will be dead. At today's world, privacy is something which is which is already in the market, but there is not even a single company can have this trust that um, it can protect her user data, and from this data only many things can happen. So of course think about it once, and please be ensured that every project or every Python project or every machine learning project or every AI project which you are building right now, it will going to affect the world. And of course, if there is any bug, then the hacker could easily get into your computer and hacked the whole thing. But if you are well known or well enough to secure this, then hats off to you, man. So now let's see by this. Sorry, let's read this article and see. Uh, and yes, if you want me to give advice, mm, that how can I easily get into this, so blockchain technology is the new thing, and everyone is looking into that. Yeah, even the transaction is very none of them can easily track the record like that. This blockchain technology is not for cryptocurrency, is also for password authentication or password, uh, or to protect user data, because it will be very protected, and not a single thing who can easily hacked by anyone. So please research about this and build a project around blockchain technology, and I think it's a robust technology. So think about it once. Now, finally, let's read this article and see what he is talking about. Over the past decade or so, computer scientists developed a variety of machine learning models that can analyze large amount of data both quickly and efficiently to be applied in real world situations that involve the analysis of highly sensitive data. However, these models should protect the privacy of users and prevent information from reaching third parties or being accessed by developers. Of course, researchers at Manipal Institute of Technology, Carnegie Mellon University, and Yildiz Technical University have recently created a privacy enabled model for the analysis and classification of financial tests. This model, introduced in a paper published on ARZIV, is based on a combination of natural language processing (NLP) and machine learning techniques. Our paper was based on our previous work named Benchmarking Differential Privacy and Federated Learning for BERT Models. Priyam Basu, one of the researchers who carried out the study, told Tech Explode. This work was our modest attempt at combining the domains of natural language processing (NLP) and privacy preserving machine learning. The main objective of the recent work by Basu and his colleagues was to develop NLP model that preserves the privacy of user, preventing their data from being accessed by others. Such a model could be particularly useful for the analysis of bank statement, tax return, and other sensitive financial documents. Machine learning is a majorly based on data and gives you insight and prediction and information based on data, Basu said. Hence, it is very important for us to delve into research on how to preserve user privacy at the same time. The framework developed by Basu and his colleagues is based on two approaches known as differential privacy and federated learning combined with bidirectional encoder representation from transformers, which are renowned and widely used NLP models. Differential privacy technique add a certain amount of noise to the data that is fed to the model. As a result, the party processing the data, example developer, tech firms, or other companies, cannot gain access to the real documents and the data as individual elements are concealed. Federal learning, on the other hand, is a method of training a model on multiple decentralized devices so that no one device has access to the entire data at once, Basu explained. BERT is a language model that gives contextualized embedding for natural language or text, which can be used later on multiple tasks such as classification, sequence tagging, semantic analysis, etc. Basu and his colleagues used the strategy they developed to train several NLP models for classifying financial tests. Then they then evaluated this model in a series of experiments where they used them to analyze data from the financial phrase bank data set. Their results were highly promising as they found that the NLP model performed as well as other state of the art techniques for the analysis of financial tests while ensuring greater data protection. This research study could have important implications for several industries, including both the financial sector and other fields that involve the analysis of sensitive user data. In the future, the new model they developed could help to significantly increase the privacy associated with NLP technique that analyzes personal and financial information. Classification and categorization based on natural language data is used in a lot of domains, and hence we have provided a way to do the same while maintaining the privacy of user data, which is highly important in finance where the data used is highly sensitive and confidential. Basu said, we now plan to improve the accuracy achieved by our model, which not having to lose out too much on the privacy trade off. We also hope to explore other techniques to achieve the same as well as perform other NLP tasks like NER, semantic analysis, and clustering using DP and FL. What a break. Now we have our next topic. It's a astronomy topic or in the space basically, in which the topic name is strange radio waves emerge from the direction of the galactic center. So there is a wave coming from the space on our uh, on our satellites, which has been discovered. So what's the wave or what's the sign is coming from their center. uh, Astronomer has discovered this, so let's read this and get to know about that what's this unusual signals are coming from the Milky Way center. Astronomers have discovered unusual signal coming from the direction of the Milky Way center. The radio wave fit no currently understood pattern of variable radio source and could suggest a new class of stellar object. The strangest property of this new signal is that it has very high polarization. This means its light oscillate in only one direction, but that direction rotates with time, said Zhang Wang, lead author of the new study and a PhD student in the School of Physics at the University of Sydney. The brightness of the object also varies dramatically by a factor of 100 and the signal switches on and off apparently at random. We have never seen anything like it. Many types of stars emit variable light across the electromagnetic spectrum. With tremendous advances in radio astronomy, the study of variable or transit objects in radio waves is a huge field of study, helping us to reveal the secrets of the new universe. Pulsars, supernovae, flaring stars, and fast radio bursts are all types of astronomical objects whose brightness varies. At first, we thought it could be a pulsar, a very dense type of spinning dead star, or else a type of star that emits huge solar flares. But the signals from this new source don't match what we expect from these type of celestial objects, Mr. Wang said. The discovery of the object has been published today in the Astrophysical Journal. Mr. Wang and an international team, including scientists from Australia, National Science Agency, CISRO, Germany, and the United States, Canada, South Africa, Spain, and France, discovered the object using the CISRO CIS, CSIRO ESCAP radio telescope in Western Australia follow-up observations were with the South African Radio Astronomy Observatory Meerkat telescope. Mr. Wang, PhD supervisor, is Professor Tara Murphy, also from Sydney for Astronomy and the School of Physics. Professor Murphy said, "We have been surveying the sky with ASCAP to find unusual new objects with a project known as Variable and Slow Transist WAST throughout 2020 and 2021. Looking toward the center of the galaxy, we found ASCAP named after its coordinates. This object was unique in that it started out invisible, became bright, faded away, and then reappeared. This behavior was extraordinary. After detecting six radio signals from the source over 9 months in 2020, the astronomer tried to find the object in visual light. They found nothing. They turned to Parkes radio telescope and again failed to detect the source. Professor Murphy said, "We then tried the more sensitive Meerkat radio telescope in South Africa because the signal was intermittent. We observed it for 50 minutes every few weeks, hoping that we would see it again. Luckily, the signal returned, but we found that the behavior of the source was dramatically different. The source disappeared in a single day, even though it had lasted for weeks in our previous escape observations. However, this further discovery did not reveal much more about the secret of the transient radio source." Mr. Wang's co supervisor, Professor David Kaplan from the University of Wisconsin Milwaukee, Milwaukee said, "The information we do have has some parallels with another emerging class of mysterious objects known as galactic centers radio transits, including one dubbed the cosmic burper. While our new object, ESCAP, does share some properties with GCRTS that are also differences, and we don't really understood those sources anyway, so this adds to the mystery. The scientists plan to keep a close eye on the object to look for more clues as to what it might be. Within the next decade, the Transcontinental Continental Square Kilometer Array SKA radio telescope will come online. It will be able to make sensitive maps of the sky every day, Professor Murphy said. "We expect the power of this telescope will help us solve mysteries such as this latest discovery, but it will also open vast new swaths of the cosmos to exploration in the radio spectrum." So basically, there is a new um radio telescope is coming, which is transcontinental square kilometer array, which is coming online. Great. So there, there's how we know the secrets of the universe. Now we have our next topic, which is welcoming composite inks into the fold. A screen printing approach to creating foldable circuits could make many functional devices easier and cheaper to mass produce. Of course, this is how many mobile phones and laptops has been created. A method that combines screen printable composite and metallic inks could make foldable electronic easier and cheaper to manufacture at industrial scale. These devices developed at cost KAUST can be mounted on various supports including non-planar surfaces and could enable many Internet of Things IoT applications. Next generation technologies such as automotive radars for self-driving cars, smart building, and variable sensor will depend more highly on the high frequency millimeter wave band, including 5G. To date, large-scale manufacturing approaches to make foldable electronics have focused on developing metallic inks and printing conducting patterns and have overlooked dielectric substrates. There have been a range of barriers to the use of substrates such as paper and some polymer films in foldable electronics. These substrates involve fabrication processes that are not constraining and complex for mass production and cannot produce multi layered or ultra thin flexible devices. They also have a dielectric loss that exceed the requirements of millimeter wave devices. Atif Shamim and co-workers have now devised a composite ink ceramic particle dispersed in the polymer acrylonitrile butadiene styrene ABS. They use this new ink to generate extremely flexible, large area dielectric substance and tunable lateral dimension, thickness, and perm- permittivity. Permittivity. They screen printed the ink on the glass onto glass and, after drying, simply peeled off the substrates from the support. The substrates presented a minimum thickness of a few microns that could be increased through successive printing passes. They also exhibited a low dielectric loss at 28 GHz, which is suitable for 5G antennas. The researchers screen printed a silver nanowire based ink on the dielectric substance to build conductive patterns. The patterned films maintain high and stable electrical performance when rolled or folded into half, a result of the polymer binder present in the ink. Furthermore, they retain their performances when incorporated into a four-layer circuit consisting of altering metal pattern and dielectric layers. This suggests that the screen printable inks can be used in multi-layer structure such as multi-layer printed circuit boards and motive automotive radars. For proof of concept, the researchers screen printed a flexible quasi-Yagi antenna on a dielectric substrate to show that the device performed well in the millimeter wave band when bent or folded. Our approach will be beneficial for novel 5G antennas and accelerate the implementation of 5G, says postdoc VV Lee. Sorry if I pronounced the wrong name. The team is now exploring potential application of their approach to other electronic devices. Lee says the both inks are compatible with roll-to-roll processing, which can help meet the high demand for variable sensor at low cost. We expect fabrication cost to be extremely low to the extent that the devices will become disposable, Shamim says. So basically, it will help in our upcoming bandwidths or upcoming uh, 5G technology. So I think it's a good idea, and I hope it will help in our upcoming 5G technology. Now we have an interesting topic, which is voice copying algorithm found able to dupe voice recognition devices. So I will not explain now. Get into dive into this article, and you will already know what I am talking about or what the title says. A team of researchers at the University of Chicago has found that voice copying algorithms have advanced to the point that they are now capable of fooling voice recognition devices and in many cases people listening to them. The group has posted a paper on the ARXIV preprint server that described two well known voice copying algorithms. Deepfake videos are well known. We already know deepfake videos. Many examples of what only appear to the celebrities can be seen regularly on YouTube. But while such videos have grown lifelike and convincing, one area where they fail is in reproducing a person voice. In this new effort, the team of UOC found evidence that the technology has advanced. They tested two of the most well known voice copying algorithms against both human and voice recognition devices and found that the algorithms have improved to the point that they are now able to fool both. The two algorithms SV2 TTS and Auto VC were tested by obtaining sample of voice recording from publicly available databases. Both systems were trained using 95-minute voice snippets of public people talking. They also enlisted the assistance of 14 volunteers who provided voice samples and access to their voice recognition devices. The researchers then tested the two systems using the source software Rhythm Blazer. It listens and compares voice recording and then gives a rating based on similar two samples are. They also tested the algorithm by using them to attempt to access service on voice recognition devices. The researcher found the algorithm were able to fool the Rhythm Blazer nearly half of the time. They also found that they were able to fool Azure Microsoft Cloud Computing Service approximately 30% of the time, and they were able to fool Google Alexa voice recognition system approximately 62% of the time. 200 volunteers also listened to pair of recording and tried to determine if the voices were from the same person. The results were mixed, but overall the algorithm were able to fool the volunteers more often than not, and especially so when the voice samples were of famous people. So basically, it's like our voice recognition Alexa and different voice recognition devices fooled by this algorithm, and I think Microsoft and Amazon need to work on this. So let's see our next topic, which is researcher relies quantum teleportation onto mechanical motion of silicon beams. Now we are again talking about quantum technology, quantum applications. Never mind, this is our new future. That's why uh, more and more scientists are discovering or developing new things in quantum technology only. Now let's read this article and see what the author is talking about. Quantum technology typically employs qubits, quantum bits consisting of, for example, single electrons, photons, or atoms. A group of TU Defelt researcher has now demonstrated the ability to teleport on an arbitrary qubit state from a single photon onto a optome- uh, optomechanical device consisting of a mechanical structure comprising billions of atoms. Their breakthrough research, now published in Nature Photonics, enables real world applications such as quantum internet repeater nodes, while also allowing quantum mechanics itself to be studied in new ways. Quantum optomechanics. The field of quantum optomechanics uses optical means to control mechanical motion in the quantum regime. The first quantum efforts in microscale mechanical devices were demonstrated about 10 years ago. Focused efforts have seen result in entangled states between optomechanical devices as well as demonstration of an optomechanical quantum memory. Now, the group of Simon Groblecher of the Kavli Institute of Nanoscience and Department of Quantum Nanoscience at Delft University uh, of Technology, in collaboration with researchers from the University of Campinas in Brazil, has shown the first successful teleportation of an arbitrary optical qubit state onto a micromechanical quantum memory. Repeater nodes for a quantum internet. Quantum teleportation, the faithful transfer of an unknown input quantum state onto a remote quantum system, is a key component of long distance quantum communication protocol needed to build a quantum internet. Just like a regular internet, distribution of quantum information between quantum devices anywhere in the world will require a network of repeater nodes. Each node will temporarily store the quantum information in a memory before teleporting it to a subsequent node, ultimately establishing long distance quantum communication. Two micromechanical resonators sharing a single quantum state. In this experiment, the researchers create a polarization encoded photonic qubit in an arbitrary quantum state. They then transport this photon over tens of meters of optical fiber and teleport it onto their quantum memory, compr- comprised of two massive mechanical silicon resonators, each about 10 micrometer in size and consisting of 10 of billions of atoms. The quantum information was stored in the single excitation subspace of the two resonators. To the text the reliability of the process, the researcher further demonstrated that they could faithfully retrieve this teleported state from the memory. Telecom wavelengths. Although quantum teleportation has already been demonstrated in various quantum systems, the use of mechanical devices is a breakthrough because they can be designed to operate at any optical wavelength, including the low less the low loss infrared telecom fiber wavelength. It is this wavelength the result in the lowest transmission loss, allowing the longest distance between repeater nodes. Groblecher says this milestone was possible due to the quality and flexibility of our nanofabricated optomechanical systems, which, unlike most other quantum systems, allow for independently engineered optical properties. A future quantum internet will be undoubtedly make use of the existing telecom network at this wavelength. Great. All the building blocks. In principle, quantum teleportation can be done over arbitrary distances by teleporting a photonic quantum state over tens of meters of optical fiber onto a quantum memory. The researchers have demonstrated the requirement for a fully functional optomechanical quantum repeater node globulature. We now have the further improved the performance to the level required for a system that can be deployed in real world applications, such as increasing the repetition rates fidelities, and the success rate of the qubit teleportation and storage. According to the Thyok Ulch, researcher at the University of Capinas and the collaborator on this project, one route will be designed optomechanical systems that are resilient to the parasitic optical absorption. This can be realized due to the flexibility to the nanofabricated devices, a hybrid approach. The current research is a big step towards global vision of a future hybrid quantum internet. We are working toward a heterogeneous network where you have various physical systems communicating and performing different functionalities, he says. You may have optomechanical quantum repeater nodes connected to a quantum computer or memory consisting of superconducting qubits or spin quantum systems, respectively. All of these will have to compatible with one another, operate at the same wavelength in order to faithfully transfer quantum information, quantum to classical transition. Beside enabling building block for novel quantum technology, the ability to calibrate an arbitrary qubit state onto massive mechanical oscillators can also be used for testing quantum physics itself at a fundamental level, whereas very small systems typically behave according to the laws of quantum mechanics. Large systems are governed by the classic laws of physics. Experiments have excluded certain theories describing decoherence mechanisms leading to the quantum to classical transition, but we are far away from definitive answer. Globacher says, as it is relatively easy to scale our optomechanical system and to use teleportation to create interesting quantum states. This is an important step in understanding this boundary. So this is our last topic uh, and last article of the stream. Uh, so let's read. And our topic is solar panels on half the world roofs could meet its entire electricity demand. So basically, you have seen or mm, you read in the news that we are facing global energy crisis. Now we have a article about solar panels in the solar panels can easily meet the requirement of whole electricity in the whole mm, Europe and China and everywhere in the world. So let's read this, how it is possible if we all can uh, all can put solar panels into on a house. Let's read this. Rooftop solar panels are up to 79% cheaper than they were in 2010. Of course, these plummeting costs have made rooftop solar photovoltaics even more attractive to households and businesses who want to reduce their reliance on electricity grids while reducing their carbon footprints. But are there enough rooftop surfaces for this technology to generate affordable low carbon energy for everyone who needs it? After all, it's not just people who own their own houses want to cut their bills who are in need of solution like this. Around 800 million people globally go without proper access to electricity. Our new paper in Nature Communication presented a global assessment of how many rooftop solar panels we did need to generate enough renewable energy for the whole world and where we did need to put them. Our study is the first to provide such a detailed map of global rooftop solar potential, accessing rooftop area and the sunlight covered at scales all the way from the city to continents. We found that we would only need 50% of the world rooftop to be covered with solar panel in order to deliver enough electricity to meet the world yearly needs. Method: we designed a program that incorporated data from over 300 million buildings and analyzed 130 million kilometer of land, almost the entire land surface area of the planet. This estimated how much energy could be produced from the 0.2 million kilometer of rooftops present on that land, an area roughly the same size as the UK. We then calculated electricity generation potential from these rooftops by looking at their location. Generally, rooftop located at higher latitudes, such as in northern Europe or Canada, can vary by as much as 40% in their generation potential across the year. Due to big difference in sunshine between winter and summer, rooftops near the equator, however, usually only vary in generation potential by around 1% across the seasons, as sunshine is much more consistent. This is important because these large variation in monthly potential can have a significant impact on the reliability of solar powered electricity in that region. That means places where sunlight is more irregular requires energy storage solution, increasing electricity costs. Hotspots. Our result highlighted three potential hotspots for root of energy generation: Asia, Europe, and North America. For these, Asia looks like the cheapest location to install panels, where in countries like India and China, 1 kilowatt hour of electricity or approximately 48 hours of using your laptop can be produced for just 0.05p. This is thanks to cheap panel manufacturing costs as well as sunnier climates. Meanwhile, the quantity are per kilometer per kilowatt per hour. Rooftop solar panels like they did be equally useful in areas low population as they in remote areas. Panels help top up or even replace supply from potential unreliable local grids. And for those in cities, panels can significantly reduce air pollution caused by burning fossil fuels for energy. It's vital to point out that globally electricity supply cannot rely on a single source of generation to meet the requirements of billions of people. And thanks to changeable weather and our planet day and night cycle, a mismatch between solar energy demand and supply is unavoidable. The equipment required to store solar power for when it's needed is still extremely expensive. Additionally, solar panels won't be able to deliver enough power for some industries. Heavy manufacturing and metal processing, for example, requires very large currents and specialized electricity delivery, which solar power won't yet be able to provide. Despite this, rooftop solars has huge potential to alleviate energy poverty and put clean pollution free power back in the hands of consumers worldwide. If the cost of if the costs of solar power continue to decrease, rooftop panels could be one of the best tools yet to decarbonize our electric supply. So that's all about for today, and I like to thank if anyone you used to read or see the whole thing or see the whole article or around the news. I really appreciate it. And yes, if you are watching this, then please follow our socials, especially Twitter. And yes, that's all about it for the today. See you tomorrow by this time only. Stay safe, stay healthy.